Assalamualaikum warahmatullahi wabarakatuh. Good evening. My name is Dimas Rizal Yuniansyah, and with a student ID number 422230120 from the Robotics Engineering 6A morning class 2023. So in this video I would like to demonstrate and to explain the code that I do for this midterm project. The midterm project is called the MNIST letter classification using HOG or histogram of oriented gradients and feature extractor and SVM or support vector machine classifier. And first things first, what is an MNIST dataset? MNIST dataset stands for extended MNIST. So basically, MNIST datasets contains a lot of types such as letter, digits, and etc. But in this term, I focus on the MNIST letter dataset. So basically, it contains the alphabets of A, B, C, D, and so on. So, and we use HOG or histogram of oriented gradients for feature extraction and SVM for classifier. And the target for this project is to determine whether the model could predict the MNIST letter dataset or not after using HOG and SVM. So first things first, we need to do the prerequisites, installation of the following dependencies. So matplotlib, numpy, seaborn, scikit-learn, scikit-image, and mlextend. So basically, this is all the libraries that we need for this project. So let's just run it. So we need to clear our outputs, and then we just do this. We select the virtual environment. For the virtual environment, I use CV_NV, and I created the virtual environment using the Anaconda prompt. Okay, so this means that the library is already installed. So let's just move to the second step, which is dataset preparation. So what does dataset preparation means? That we need to prepare for the data set so that we could like pre-process our data sets. Okay, and then the first thing we need to do in this step is to importing the required libraries. So it will take a while. Okay, 1.4 second. And right, and all of the libraries it is required for the project, such as HOG, SVM, and train test split with search CV, and these three: classification report, confusion matrix, accuracy score, and local MNIST. So this is for the feature extraction. This is for support vector machine classifier. This is for LOOCV or leave one out cross validation. So it means that we could like split the data set into two. So we could split it into train and test. So for this project, I use the 80% on train and test, 20% on test. And for the grid search CV is for to finding the best parameters for the model. And all of these three, it is for the result of the model. And the main target is these three. We need to like know the value of all of this. We need to know the accuracy, we need to know the precision, we need to know the recall, and we need to know the F1 score of the model. And then local MNIST is to for the MNIST dataset itself. So to confirm whether the data is already downloaded, I created this variable. So this variable contains the function for the library for um, detecting the MNIST dataset, and I created two variables here: image underscore path and labels underscore path. And for the dataset, I use the trained images and the trained labels. So let's just use this. Okay, it means that we already downloaded the dataset. So we move to the next step. So I'm going to visualize the MNIST data. So I use like Okay, data label 0, 28, and 28 is for the amount of pixels on the data set. So let's just move. And I use matplotlib to show this, yeah, to show the, sorry, to visualize the data. Okay, so label 23. So this is basically the view of the MNIST data set. So basically it's a handwritten data set. And since computer could not detect like accurately compared to us humans, because humans have neurons, and humans got this like brain and neurons to perceive things. So as a human we could see this clearly, like, okay, this is clearly a W, but to computer, for computer, it needs a lot of work to perceive or to predict whether this is W, or this is an N, or this is another alphabet, or even a number. Okay, so we need to see the amount of total images. So I use this. Okay, so this is a lot of images and labels. 124,800. For this project, we use 2,600 samples only, because we need to balance the dataset also. So this is for to begin from 0 to 1. So okay, and then I created this right, this array and this loop to determine the results. So okay, and then if the loop doesn't work, or it doesn't like met the requirements, uh, it just print the class has only samples and skipping. And also I created this subset. I created this variable and print the shape, or the value, or the amount of the data set. Okay, so this is 2,600. This is what we want. So basically, the X and Y subset is quite balanced. So we can move to splitting the data. So in this, we use train and test, and the test size we use is 0.2, means that we use a 20% on test, means that we use 80% on train. So the random state is 42, and we could see the amount of the shape. Okay, so this is 2,800. Oh, sorry, 2,080 and 520. So it's quite balanced. So move on to the feature extraction using HOG, or histogram oriented gradients. So we use this is the parameters that we can change. So I change it to the orientations is 8, pixel per cell is 4, and 4 by 4, cells per block is 2 by 2. And we can visualize it using matplotlib. Okay, so let's just run. Okay, and then the HOD feature is to determine whether a digit, the edges could be detected or no. So it means that all of these, the feature value and the feature index are shown in this graph, and we can see the like we can see all of this bar represents the numbers of samples. Okay, so next I create this function called hawk underscore features, and this includes all the images, the orientations, the pixel per cell, the cells per block, and create the features to I create this variable features, and I create this loop. So feature consists of the image reshape, 28 pixels by 28 pixels. The orientations are orientations. Pixel per cells are pixel per cells. Cells per block are cells per block. And return it as a numpy array. So let's just run it. Okay. And then this is the parameter that I use for the feature extractions. And this is the training and test for HOG feature shape for the training set and for the test set. So it resembles this number, so 2080 and then the 520. So all of the feature extractions are done. So we're moving into classification using SVM, so super vector machine. So the first things first, we need to determine the parameter for the SVM. So there are three parameters that I use on SVM is basically C or regularization, kernel, and the gamma. So this is the parameter for SVM. So just run it. And then this is the SVM. So for grid search, we use grid search CV to find the best parameters. Okay, and then we use grid search.fit, and we use the X train and Y train of the dataset. For the X train, I use the dataset that already using the HOG feature extraction. Okay, so it will took a while to find the candidates. So this is the number of candidates of the parameters, and the difference between running the program on a Visual Code or any uh, text editor and GitHub. On GitHub, it will resembles uh, it will just not just not resemble the HTML form, unlike Visual Code. So it may be a little different, and it will take a little while to find the 18 candidates for. Okay, so it took us an entire 47.3 seconds. So this is the grid search CV and the parameters. Okay, and then for the best estimator, we use the regularization is 10, and for the parameters of the SVC, we use this. So for the kernel, we use RBF, the degree is 3, the gamma for, oh, sorry, the value of gamma is scale. And then for the max iteration is -1, and the random state is none. Okay, so after we use grid search.fit, so we can use the grid search best params for finding the best parameters, and we could print the performance of the X test and HOG test. So previously we use xtrain xtrain underscore HOG dataset. Means that we could use the train dataset into tests. So we could see the past parameters for it. We can see we use C as 10, gamma is scale, and kernel is RBF. So for the performance of the grid search best estimator dot score is 0.83, means that it's around 83%. So for the best model, we use this. Okay, so after we did feature extraction and we did classifying using an SVM, so we need to evaluate all of the criteria and the results of the SVC and the result of the SVM and the um, HOG feature extraction. So we need to see and we need to like see the value of the classification report. Okay, so we use this. Okay, so means that this model could predict accurately, and it has an accuracy around 0.83, means that the model is around 83% accurate. And the classification report includes all of this, so the precision recall F1 score as seen in here, and the accuracy for it is shown also in here. Okay, so and after we evaluate and we get all the values from the classification report and the accuracy, we use confusion metrics to determine whether the model is could predict uh, predict the MNIST letter data set or not. So I use SNS for data visualization, and I use Matplotlib for the graph to show. Okay, so this is the confusion metrics that um, yeah that this line create. So it is divided into two. So we in here we have true label, and here we have predicted label. So it means that this so if the predicted is A, and then the amount of the sample is around 1, and then it follows as the letter in the data set. So after we get the numbers, we get the best parameters, we do extractions, and we use support vector machine. We could use this for prediction. So in this, I create a loop for I and enumerate, so indices. So we use the test data set and reshape it into a 28.28 pixels. So I create the variable, the true label and pred label. So this is the y test prediction and the subplot and of the criteria for the prediction. And then I use Matplotlib to visualize the result. Okay, so uh, so here it is due to the import random library and NP random choice. So basically, it the orientation of the MNIST dataset is quite random, but it shows so the true so this is the true is T, and the predict so the model predict T, and this is the true is V, it predicts V, this is O, predicts O, and so on. So in conclusion, that this model could predict MNIST letter dataset with an accuracy of 83%. So it means that this model has a good accuracy to determine and to predict whether this letter or this MNIST letter dataset uh, is because since it's handwritten, so it means that the model could predict handwritten letters. And I think that's pretty much it for this video for computer vision midterm project. If I have any mistakes in my program and in my uh, in my explanations, I apologize for that. And thank you for watching. Thank you for your attention. And Assalamualaikum warahmatullahi wabarakatuh. Good evening.